Hello there, and welcome back to another episode of All Around Azure. Really excited for today. My name is Jason Hand, and we've got a guest today who I haven't seen forever, and I'm so excited to be able to chat with him and hang out. We're going to be talking a little bit about security within the space of serverless. So there'll be some stuff around functions. And you know what? Actually, instead of giving any more like spoilers about what we're going to be talking about, let's just bring him over and say hello. So everybody, please welcome our guest, Dean Bryen. Hi, Dean.
Hey Jason, how's it going?
It's going really well. How are you, buddy?
I'm good. It's nice and warm here in the UK, so no complaints.
Cool. Well, glad you're doing well. It's good to see you. We got a chance to just kind of catch up a little bit before we started the stream here today. And there's a bunch of stuff you've been working on. I'm glad our schedules worked out. We could get you on the show today and talk about some of those things. So yeah, first of all, why don't you give the people who aren't in the know of who Dean Bryen is, give us a little bit about your background, and then what kind of stuff do you want to like jam on today?
Awesome. Yeah, hey folks, I'm Dean Bryen. As Jason said, I'm based here in the UK, where it's currently sunny, but it's not normally, so I'm enjoying that. I'm a principal cloud advocate at Microsoft, and I focus predominantly on security and a little bit of DevOps, like DevSecOps stuff. I've been doing that for quite a while now around kind of security and DevOps and architecture around the cloud. I previously worked at AWS and a smaller cloud provider, and I've been at Microsoft now for a few years. I focus a lot on serverless technologies, and that's really what I want to talk about today is around security and serverless. And yeah, it's just a bit of a conversation with you, Jason, around how we can about that kind of topic, and hopefully dive into some demos and play around with some stuff and show people how we can break some stuff. We're gonna wear a couple of hats, right? I'm gonna I'm gonna build some stuff, show some code and stuff, and then we'll deploy something, or we'll either deploy something or use something I've already got deployed, given see how much time we have,
Mm-hmm.
and then we're gonna put on our black hat and we're gonna hack into some stuff and show how if you do things badly, like nasty people can do nasty things, and then but then we'll flip 100% and we'll turn good guy again, and we'll start fixing up some of that stuff and see how we can make our serverless apps a bit more secure.
Yeah, yeah. Fun. Well, that sounds awesome. Yeah, one of the things we were talking about before we got going here is how there's such a huge, there's not only a gap of information on security out there, being like one of the biggest and most important topics there is. But there seems to be like a growing thirst for this stuff too. I think people are starting to realize the importance of securing their stuff, especially in the cloud world. So I think this is all very timely, and really excited to put on both the black hat and the white hat and go break some stuff and then protect ourselves. So a little bit of housekeeping for those of you joining us. I'll be keeping an eye on chat for Dean. So just put any questions you might have. Feel free to drop those in there. Say hello. And if we're going to be sharing anything, some resources that Dean might have for some of the stuff he'll be showing off, I'll be putting those in chat for you as well. And just like always, these will eventually be saved on a couple different places on YouTube, as well as on our own site, which will be at allaroundazure.com, coming very, very soon. As well as some other exciting things around potentially having some stuff on Learn TV. So with that, Dean, do you want to give us a little more explanation, or should we just dive over to your screen and you can start showing us what you want to talk about today?
That's just a couple of things I kind of always like to kind of mention
Okay.
first, really, before we. I think one thing that's really interesting is that when we talk about serverless, and especially when I do a bunch of demos on serverless security and like hacking into serverless apps, people are like, wow, like he hacked into that app really easy. Like serverless must be so insecure,
Mm-hmm.
right? Like and it's not, right? The point is like when we people watching this aren't familiar with serverless, right? We've kind of that evolution of application architectures over time as we've moved from like on premises to infrastructure as a service to platform as a service. You've all seen that diagram, right, where it goes less and less this direction. The
Mm-hmm.
cloud provider looks after more. Like serverless is right at the right hand side of that graph. So I think it's really important to kind of just be like you're more secure like naturally by using serverless, right? Because you're leveraging the cloud provider security, right? Microsoft spend over $1 billion a year on security, right? I'm pretty sure most
Yeah.
other companies don't do that. If you do, like, great, but you're probably not doing that on securing cloud resources. And if you are, you're probably a competitor. So I just kind of think it's really like, I'm going to break into some stuff for sure. And obviously, there's nothing that's unhackable. I guess the point of this really, and you'll see as we go through this actually, is that this stuff, if you have bad practice, then like people can break in. Like Orin Thomas, who's on our team, who does some security stuff as well. Like, he always has like a great quote, which I think it is actually from Gartner, that comes up. So like 95% of security breaches in the cloud this year will be the customer's fault. Right. So it may have even got up from 95, but it's at least 95% of cloud breaches this year.
Yeah, and it's always. Have you seen recently? I haven't looked at it in a long time. Like, where was that? There was something that showed off all of the like open source projects out there that have known vulnerabilities and like how many people are using them.
It's actually crazy. Like lots of people, and that's funny because we're actually going to look at some of those today.
Yeah.
Like, we'll look at some of those in a bit. And like the National Cybersecurity Centre in the UK, we'll try and find the link and share it. They wrote some great articles advising UK government to use serverless, like promoting it as almost as a security benefit, right? You're inherently more secure by using these high level services because there's less that you have to worry about, right? There's two things we really care about when we're building serverless apps. And as a security professional, or as any developer or administrator or whatever, the things you really care about when you're dealing with serverless is your configuration. This is the configuration of your cloud resources, maybe our infrastructure as code, or just literally the configuration where we deploy stuff via the portal. And the other thing is our code, right? Like and I'll say this 100 times before we end this, unfortunately, but like AppSec is AppSec, right? If you're running apps, you need to adhere to AppSec practices, and this will all come apparent to people why that is, and hopefully we'll have some compelling examples to show why. But as you said, on the open source thing, the National Cybersecurity Centre did another bit of research around vulnerable dependencies in code and vulnerable systems that were running within government bodies and organizations, large organizations in the UK. And it wasn't whether they were running vulnerable stuff, but it was like stuff that hadn't been patched for more than 30 days or something like that, which obviously would have had vulnerabilities if it was like 30, 90, 60, 90 days plus. And it was like I won't quote exactly, it was in the multiple tens of percentages of stuff that wasn't patched in like the last 90 days, right? And if stuff wasn't patched in the last 90 days, you've probably got vulns.
Totally.
So.
Yeah, I guess I hadn't thought of it that way, but I mean, we've abstracted so much away in the serverless world where you don't, even though there's still networking and there's still hardware, it's not something you need to worry about. So I guess if we're effectively reducing your surface threat at that point, right? I mean, because like you were saying, Microsoft is already on it for a lot of that stuff. Using economies of scale, thinking like, why don't we just let them take care of all of the threats and we can focus on just the code. So that's pretty cool.
Yeah, exactly. So yeah, I kind of just like to kind of make that clear that you can always break into stuff if people do bad things, right, or bad practices. But yeah, it's a pretty good starting point to use serverless. So don't let this, if you're watching, don't let this put you off using serverless. And the other thing I just want to mention is because it's funny, somebody threatened to report me or something last time I did like something similar to this on Twitch, because they joined like midstream and they didn't realize that it was like my app that I was breaking into. So yeah, just for the record, like the app, like when I break into stuff, anyone watching this, like I own the resources. I have permission to run ethical penetration tests against the environment. So yeah, if you join this and you think, what's this guy doing? He's like hacking on Twitch. That's not allowed. But it's an application that I have full permission to do this with. So yeah, it's all mine, and whatever I break will be my fault. So I can deal with the consequences.
You'll probably be deleting these things after you're done too.
Yeah, I don't leave these vulnerable things sitting around in my account for too long. If I do, I have them all like disabled, so like there's no public endpoints and stuff like that. Right. So
cool. All right. Well, I'm super stoked. I can't wait to see.
Yeah, nice. So you can. So yeah, go ahead and share my screen.
Switch over. All right, let's take a look.
Yeah, let's go for it. So you can see I'm in VS Code, right? You can see that.
We're looking at your browser in Grok Inspector.
Oh, that's my fault. Uh, you're looking at my browser. That's weird.
Mm-hmm.
Are you seeing get?
The one that says there
It
was
says
an
like,
error clearing the requests.
yeah. I wasn't even on that tab.
Huh.
What the?
Oh.
Let me.
Right out of the
Shall I
gate.
stop and start? Shall I stop and start again? Let me
Uh,
stop sharing my screen
you
and
want to
then.
stop sharing your screen? Let's just go back to side by side here, and you can try reset that.
Yeah, cool. Right. You know, you can't beat some good technical issues.
That I've learned as I'm looking around at all my different screens. I've learned is just how this thing works. Things break, we roll
That
with it. I think that's why I enjoy streaming, because it doesn't have to be perfect.
Yeah,
Okay.
exactly right. Yeah, I did a meetup in the Netherlands, and luckily my screen was fine, but like me, I was completely invisible. Like you could just hear me. The NDI thing was playing. Anyway, we can
Yeah.
worry about
Okay. Well, so
streaming.
now we're looking at
Methods.
GitHub, and we're looking at the
All right,
generate reverse
cool,
payload bash script.
cool, cool. So you should be able to see. I'm gonna flip over to VS Code, right?
Okay.
All right, we're good.
We're good now.
It's a bit bigger. So I've got basically a super simple serverless app here. It does a couple of things, right? If people aren't familiar with Azure Functions, then it's actually quite interesting. You deploy your functions in Azure into what's called a function app. And a function app is like it's the host, right? It's the underlying instance that your code and your functions run on. Why this is really important from a security standpoint is that function apps have they're like a boundary for a lot of things. They're like the scaling boundary, like the instance size boundary. They're also like they're a security boundary, like the identity boundary. You can have more than one function within a function app. So if you have like 4 functions on a function app, like all of those functions have access to all the other functions. They all share an identity. If you're using managed identity, so managed identity is a way for us to give our functions access to other resources in Azure. So it's really important to know that you deploy your functions to a function app, and it's not a one-for-one thing. And this is important for people that have used other cloud services for functions. Like if you use Lambda, and I believe Google Functions as well, just to put like the 2 other main out there, those are quite different. They don't have this concept of a function app, right? They have you have like a function and that's it, and then you have another function, that's it. And the function app model is just different. It's like if you or I, Jason, were tasked to go and build a bank's infrastructure, right? We'd do it differently, right? So we've just done it slightly differently to others. And it's also built on top of app service, and that kind of model is familiar with app service, right? App service plans and apps that sit within those plans historically. But that's really important, and we'll come to why that's important in a bit. But so here I have a function app. So a function app is like this source folder you can see here. I might be able to make that a little bigger. And then in there, I have a few functions. But the point is that the actual resource in Azure, like when you deploy stuff in Azure, if people watching this have deployed stuff before using ARM or anything like that, the resource is the function app. And you give the configuration there, right? You say what function app you want, what kind of plan you want, and a few other things. If you want to add functions to that function app, you don't actually really have to do anything in Azure. You can just add an extra function to your folder structure that you deploy to that function app, if that makes sense.
Mm-hmm.
So I have like these 3 folders here, like add speakers, get speakers, right? If I wanted to add one called delete speakers, I would just create a new directory here called delete speakers. And then within that, I need 2 things. I need a function.json file, which is the configuration for that specific function. And then I need an index.js file here because I'm using JavaScript or
Okay.
main.py or whatever it was if you were using other programming languages. So it's just for me, it's quite cool. I can just add another function by just adding another directory and then just hitting deploy and then deploying this whole source directory to Azure Functions, to my function app, and ta-da, I've got another function that just works. And I've not really had to use any ARM templates. I've not had to configure that using anything like that. So the 2 main components, just so people are familiar with the functions, is this function.json file. This tells us a little bit about our function, right? And I'm starting to give away a little bit of the secret sauce here. And the eagle-eyed among some of the viewers might be like, why is he doing that? Like, that's bad practice. So if you see anything like that, like, pop it in the chat, or just let us know you've seen something, and later on you can tell me whether you found something that we don't leverage later or break later. But ultimately here we have the authorization level for the function. You can have anonymous, you can have function here, which gives a function key. So when somebody queries that endpoint, they have to pass in a key, or you can have admin, where they need to have like a master key to authorize with the function. And then functions have bindings. We can have input and output bindings. Input bindings are something that happens when the function is invoked, and output bindings are something that happens upon the completion of a function. And that's how we enable HTTP. And again, this might be different if people are using AWS. In AWS, you need to chuck an API gateway in front of the Lambda function to get a HTTP endpoint. It's kind of natively built into Azure Functions. Although you can put API gateway in front of it if you need the benefits of an API gateway. If you just need a scrappy, quick HTTP endpoint, you can do this. So here I have a binding here. This is of type HTTP trigger. This is saying I want people to trigger my function using HTTP. The direction is in. The name of it is rec. So I will use this name within my code to reference this binding. And the methods that I support are get and post. Right. So I'm allowing people to get and post on this specific add speakers function. And then in order for me to respond, I need an output binding. Something's happened when my function completes. So I'm going to respond to that HTTP request. So I'm going to do a HTTP output binding, and that name is going to be res. And then I've got another binding here, which is another output binding that says when this function is complete, I'm going to write to a table. So what this really simple app that I've built does is you give it a speaker. It's like when I say speaker, it's like you or I, Jason, speaking at an event or something like that.
Right. Okay.
You give it a speaker, you give it some details, and then it's going to add that to Azure Table Storage. All right, so you can write some code to add it to Azure Table Storage by all means. But this bindings feature in functions is pretty neat because I can actually say, right, there's actually a built-in table binding here. Nice. So all I need to do is I can reference the connection string. So this is stored within like my environment variables with my app. So whatever environment variable is called speakers table connection string, I will use to authorize this table. And I give it a name, speakers binding. It's table. The type is table because we're talking to table storage. The table name is speakers, and the direction is out. So as soon as my function completes, we're going to write something to this table. And in my code, again, I reference the name of this binding. So I speaker binding. So when we go to the code, index.js, which is the other required file, you're going to see in here that we've got a JavaScript function here. We're going to log something out. We're going to serialize the body from the speaker. And then what we're going to do is we're going to write the, what have we got? Yeah, so we've serialized the body from the request here into something called speaker details. And then we're going to write those speaker details as a JSON file to the /temp directory. This is another thing that's important, right? Win functions, there's only one place you can write, and that's the /temp directory. Because of the permissions model, you don't have permission to write to any other directories on the underlying host. The only directory you can write to is /temp. Remember the bit about function apps? This is important because every single function in your function app, they share a /temp directory. So this is something to just bear in mind from a boundary, blast radius kind of standpoint.
Okay.
So we're going to write that file. We're going to write that file. It's fine. And then we're going to just we're going to call the context.bindings.speakers binding. Do you remember that? This is what we called that table binding. So this is where we're just going to, and basically we're going to push something called item out to that table, which is actually the body of the request. So basically the body of the request, which is the which is what we gave the speaker details, right? And you're going to see that in a moment. We're going to push that into the table. And this is how simple it is. We just write context.bindings.speakerBinding.push, and then we give it a JSON object to push to the table storage. This is where I'm saying we could write and this isn't a security thing, this is just general coolness. I love bindings in functions. I think it's pretty cool. We could write a bunch of code and import the node module for Azure Table Storage and then write some code to authenticate to table storage and then push an item to it using JSON. Or we can just do this like one line and push an item into our table storage because we've already configured that as a binding, leveraging the connection string and all that kind of stuff in a more kind of secure manner. And repeatable. Like bindings are really cool because if I've got like a dev environment, a QA, and a prod environment, I can just change like my bindings quite easily, right? Rather than having to change my code. Or I can just change a connection string in my binding, and my code stays exactly the same. I can actually change my table in the backend completely in production and do a migration somewhere else, and my code doesn't change. I just change the connection string. So it's pretty neat.
It's the microservices approach. Doesn't matter what's on the other side. We're just passing information back. Yep.
Exactly. And then so then all we do at the end is we send something back. We say thanks for submitting your details. We were very polite. We give them their name back, and that's it, right? And then if there's an error, we're going to send back a status 400 back, right? Because there's been an error. So a super simple function, right? We give it a JSON body. It takes that, it writes it as /temp, it adds it to the database, and then it goes ahead and lets you know that it's been submitted okay, or throws an error if something doesn't work quite right. So we don't really care about the other functions here right now. They're more for vanity reasons. We really care about this add speakers function is what we're going to focus today.
Okay.
So that's what we've got, right? We've got a really simple serverless app with a function. Now, if people want to deploy this to Azure, and I probably won't deploy it now because I've got one that I can already use. But there's some really cool extensions for Azure Functions here in VS Code, and I'm sure other people maybe on this show or future people on this show will dive into serverless generally a little bit more, or have already done so.
Yeah, we've had a few. We had Brandon Minnick on here doing it. I think was the first one with me talking about .NET functions.
Nice.
I don't remember what all we went into in terms of VS Code extensions, though.
Nice. So you can sign into Azure here, and it will list all of your functions, and then you can just press this arrow here, and it will deploy it to Azure, right? Damian Brady on the same team as me, his famous saying is, friends don't let friends right-click publish, right?
That's right.
This is a demo environment. You shouldn't be right-clicking publish, right? I didn't right-click, actually.
There's exceptions to that rule, I think. Static website, I deploy right-click all the time.
Nice. Yeah, that's a fair point. Really, you should be deploying this via a pipeline, right? You should perform some kind of testing.
Exactly.
You should have only your build agents or your deployment agents deploying this with the permissions to deploy to production with release gates and all that kind of stuff. But this isn't a DevOps session, so we're going to click. We would click the publish button.
This is YOLO TV, man.
Yeah, exactly. We're here. We're living in the moment. We don't have time for that DevOps stuff tonight, Jason, unfortunately, or this morning, wherever you are in the world.
Yeah. What time is it here? It's 12:30. It's noon lunchtime.
Yeah, we're nearly 7:30 here, so PM.
By the way, I want to say thank you so much for staying up later on a weeknight and doing this with me. I appreciate it. You joining us from what part of UK are you in?
I live about an hour from London, so I'm in a place called near Sevenoaks in Kent, which is the Garden of England. Apparently, it's where it's where the world was created. I think
really?
It's like where the apples fell and like Adam and Eve and all that.
Right there next to your house.
Yeah, in my backyard. Yeah, with my fake artificial lawn. Somewhere near here, apparently. It's the Garden of England, they call it. It's a beautiful part of the world. Yeah.
Cool. Well, I hope to get back there again one day.
Yeah, I would love to have you back. It was great last time hanging out. So
who knows if we'll ever get to do that again.
In fact, we were in London and then we hopped to Paris. Like, was it London then Paris a couple of days after us?
Definitely in Paris.
Or was it not? I think it was Orlando then Paris. Man, that was a crazy couple of trips.
I don't know. They've all run together, and it feels like it was 10 years ago now. For those, Dean and I are on the same team, although we've kind of like diverged a little bit. We're still part of the same team for the most part, and we did a lot of traveling together for the Ignite the Tour, and that's like the only time we got to see each other is when we met up in some city. So it's good to do this with you.
Yeah, it's nice. Yeah, and I must come over to where you are as well at some point. I'd love to come to the mountains.
Mm-hmm.
The fun part. So we would click publish here and publish because we're trying to wind Damien up basically. But I already have something running in my Azure account. I can show you what I've got here. I've got it's actually here. I'm on it. So it's a function app. It's called Serverless Security Demo, and I've disabled it. So I'm going to start that start that app up. So
Okay.
so it works. As I said earlier, when I'm not using this stuff, I disable it. People watch this, see this URL, and they'll go ahead and hit it, and they know it's vulnerable. So
Totally.
yeah, don't try this at home, folks. So this should be working. I can test if it's working pretty easily. I've got Postman open here. So Postman, the REST client for testing out my APIs. So I've got like a really simple, like non-malicious request here to this app. So I'm just going to go like username Dean Bryen, some fake date of birth and address and phone number and all this stuff.
Okay.
And if I hit send, all right, so we've got thanks for submitting your details, Dean, right? So that works, right? The function app's up and running, right? So everything should be working as we expect, right? Our table storage should have an entry for this speaker, and it's up, right? But what I want to focus on really first is like kind of flipping ourselves into the mindset of the hacker, right? And thinking, right, okay, well, how does a hacker even get to attack an application like this, right? How do we like, where would they start? Like we know that there's an endpoint, right? We know the URL is like serverless security demo.azurewebsites.net, right? But that's like, well, that's all we know, right?
You know it's listening.
Yeah, you know it's up and it's listening. So the first thing we'd probably want to do is work out like what this body should be for a request, like so that we can send a request to this API. And that's generally pretty easy, right? For public APIs, because like say this had a front end website, which my front end skills suck, so there isn't a front end website. Maybe one day I'll add some nice fancy front end to this. But say there was, right? You could just inspect the request and you could look at the XHR request and you could see that there was a web request going out, right? And you can inspect the JSON body of the request and you say, okay, well, it looks a little bit like this, right? That's one way to do it. And if we did that, there's a few things we wouldn't know. Like we wouldn't know which of these fields are required. Like it may only want one field, right, to work, right? Or does it need all the fields, right? We don't really know that right now. But at least it would give us an idea, so we could send a request from a client like Postman, or we could automate some kind of some testing on the back. But this is called reconnaissance, right? And everyone thinks at this point like the hackers put on their black hoodie, they put their hood up, like their sunglasses go on, right? And then the lights go off. And they type like, I don't know, like override into the system as well, right? And then like
sudo, don't forget that.
Yeah. Oh yeah, don't forget that. Yeah. And then like everything just crashes, right? But this is probably one of the most boring parts of like that whole offensive security process, right? It's like trying to find as much information out about this application as we can, and that's exactly where a hacker would start, right? So they go and do some really, really simple things like. And we've almost just kind of just done that a little bit by doing this, right? So some things that, and if people notice anything like they're watching this, they notice anything, like mention it in the chat, like that you've already noticed. Like we're in the recon mode now, we're about to hack this app. So if you see anything that's like untoward or why is it built like that, hit us up in the chat, and I'll be keen to know if you see it.
Okay.
So there's a couple of things that we've already learned from breaking into this system, right? So first of all, we know from the URL that it runs on Azure, right?
Yeah.
It says that Azure websites.net, right? So if you're familiar with Azure, and some hackers might not, but they could easily go and learn this, that is probably Azure App Service of some sort. We don't know that it's Azure Functions yet, right? It could be running on Azure App Service or App Service for containers or anything like that. Right. We know that it expects like a JSON request. It's using JSON because we've inspected this front end that doesn't exist, that I'm pretending that I've already built and I haven't. So that's some things we already know. The eagle-eyed among you may have realized like a little thing here, like it's accepting requests on HTTP,
but not over the secure. Okay.
So we're accepting requests on HTTP, not HTTPS, and that's bad. You shouldn't do that. And
red flag.
Yeah, exactly. And there's other things like we actually know just from this request response here that it definitely requires the speaker name field.
Oh yeah.
Because it sends it back to me. Right. The other thing to be eagle-eyed about here is if you look at it from an offset perspective, and if anyone is interested in like offensive security and ethical hacking and all that kind of stuff, whenever information is passed back to you, this is potentially a way that you can get information out of the system, right? So if we could we know that it's leveraging that field somewhere, so that could be a way to put like malicious code in, for example. But it could also be a way that if we could somehow manipulate the like this in our code is called speaker name, right? If we head back to our code, I think it's called that. Yes, speaker name. All right. Thanks for submitting your details. Speaker details.speaker name, right?
Yep, right.
So if we could somehow like inject some code up here that changed the value of speaker details.speaker name to something that shouldn't be exposed from the application, right? Like a key or something like that. We can send that back, right? Because we know that the application presents that data back to us. And that's sometimes an avenue that an offensive attacker may use to try and send data back. So we can think about that. We may be able to use that later on to our advantage to get information out of the system and leak information. The other thing we didn't look at was the headers, right? What headers is it sending back to us, right? The response headers from the system. So one that gives a little bit away here is this header here, the server header. Says that it's using Kestrel. So Kestrel is a cross-platform .NET implementation. So this tells us something interesting. This tells us that this is Linux. If this was a Windows, because Azure Functions, by the way, you can choose whether you have your function app running on Linux or Windows. Windows would respond here telling us the server was IIS.
Okay.
So we know that they're using Linux just from this information. So that's a little bit of just knowing Azure a little bit better, right? Understanding the environment that you're working with, right? So as soon as you've seen this is Azure websites, you know it's Azure. All right, what does Kestrel mean, right? Well, you can just Google like Kestrel server and it'll tell you it's like a cross-platform. Go and deploy a Windows one, see what response you get back, right? This is what an attacker would do in their own environment to see what was different, right? Always does that tell me that? Does it not? So we've already learned quite a bit about this application, right? So we know that it's Azure. We know that it's not enforcing HTTPS. We know it receives a JSON object. It's expecting the speaker name. And this is just from sending it one request.
Yeah.
This is
and it's on Linux.
Yeah, and it's on Linux, right? The one thing that we haven't really mentioned at all is that we're adding data to a database with zero auth, right? Like we're just adding speaker details into a database without authorizing like at
anything.
All, right? So that's pretty bad. Like we shouldn't really be doing that. And as I said right at the start, like this app is purposely bad, right?
Right.
This
we should have titled this show, "This isn't how you do it."
Yeah. This isn't what Dean would really do. If anyone's looking to hire me in the future or anything, like this isn't how I would build it, right?
Sometimes you gotta make a mess to show, how to avoid a mess.
Exactly. Yeah, I won't be putting this one on my my CV, like coding examples or something. So we found that out, but there's some other cool stuff we can do here, right? We can find a little bit more out without really doing anything here. So one thing that we can do in the request body is like we can just delete it, right? Does that work? Right, and we just send this without any body, right? So then we get that 400 back. Remember, if there was an error that in our code we sent a 400. Headers look the same, but if we look at the body, there's some we're sending back some kind of stack trace, right? So now we find out more information, right? So we know that it's we've got this stack trace at line 18 of an index.js file. So now we know they're using Node.js, right? So we've got Node.js that expects JSON. There's no auth. And we now know that it's using Azure Functions because here we've got this Azure Functions host as part of the runtime that's being sent back to us in this stack trace. So we're starting to find a little bit more information out about this just from just
building a profile.
Just unordinary things. Like this is how you do this stuff, right? You just do unordinary stuff, right? just throw stuff at it that you wouldn't expect, right? And then see if the QA team and the testing, because that's what testers do, right? I'd always make quite a good tester, right? Just like do things like cancel the basket in the middle of the transaction, like see what happens on the back end, right? This is kind of what we're trying to do here, really.
Yeah.
So we found a bunch of stuff out, right? I'll list again. We've got Node.js. We know it says JS, but we know it's Node.js because we know when it says Node here, and we know that Azure Functions supports Node.js as a runtime, right? That's the language that it supports. We know there's no auth. We know it's Linux on Azure Functions. HTTPS isn't enforced. We know it receives a JSON object and it's expecting a speaker name value. So there's a couple of things we can do here as an attacker, we can take that information and try and see what we could find out. We'd probably send a bunch more requests than this, but we don't have all day to kind of dive in and talk about that stuff. So, but literally, like, what you could do is say, right, okay, well, it's Node.js, it's JSON, like, what's going on? So generally, what you would do is you would like Google with Bing, all right, like node.js JSON exploit. Right, this is me being like a bit simple around this, but like potentially, right? And this is what like any kind of like maybe a web vulnerability scanner or tool would probably try this. But literally, the first thing that comes up is from ExploitDB, right? And if you haven't looked at ExploitDB, it is fantastic. It's got like every single like CVE or exploit that's out there. It basically tells you what it is and how to do it. And this is a great resource for security professionals. Not for bad guys, for security professionals. That's what it's designed for. And the yeah, so you can see like OPSECX, right? So if you actually click, look up these folk, you can actually find like a full report on this vulnerability and how it works. But basically, it leverages vulnerability in the node serialize module, which is an NPM module in mode. So if anybody's serializing data or deserializing, in this case, particularly deserializing data using this module, it's vulnerable to remote code execution. And as we all know, like that's the crown jewels, right? Once you've got remote code execution, you can do whatever you like. So
pretty much, yeah.
They might not be using this module, right? We don't know that yet, but it's definitely worth a shot to find out and see like if they're using it. If you go to like on npm.js, this package, I think it tells you how many downloads it gets. It gets like 2,000 downloads a week. Whoa. This module. And then literally like it tells you like somewhere here, like don't use this.
Seems like it should be like right at the top.
Yeah, I can't remember exactly where it is. Like it might be on there like the GitHub repo or something. It's like do not use this unless you know what you're doing.
6 years old.
They're like here, like security warning, right? There's a security warning right at the top.
Right. There it is. Okay.
It literally tells you the exploit here as well. So yeah, this is like and it's the other thing, you know, like the one thing that gets me is if you do like so Node, what are they called, like Node Security or something like that, who do like npm audit. Basically, it became npm audit. So you can run npm audit on your function app, right? And it will tell you like all the vulnerabilities it's found, right? But also whenever you do npm install, it tells you that there's a critical vulnerability, right? But it's like this tiny like one line. It's red, but it's like one line, and people probably ignore it, or like there's a bunch of install stuff, so you don't really like take note. All that happens on your build machine, right?
Exactly. So unless you're going back through the logs.
Yeah, you're not necessarily seeing that, right? So I'd like to say it's easy to include these vulnerable modules. I'd prefer to say it's easy to not it's easy to find them, right? So but you need to be using a tool to do that, and we're going to talk about like we'll talk about in a bit is how we can like prevent some of this stuff from going on.
Gotcha.
But basically here we have a vulnerability, right? So we've Googled this, we found this, and we're going to have a go at it. So ultimately, in the payload that you send to an application, so if they're using this command in JavaScript, serialize.unserialize, and then taking a payload, right? Hint, hint, our code might be using, where is it doing that? Serialize.unserialize, and then a payload, like our code might be doing that, hint, hint. Then it's vulnerable to this remote code execution. So all you do is you give it an attribute. This can be called anything. Here they've called it RCE. And then this is the exploit here. It's like running some function up to there. And then makes it bigger. Yeah, bigger's better. Yeah, let's allow some cookies, right? So this bit here is like the kind of exploit where it's like this underscore $ND. And then inside these quotes here is some JavaScript code. This is the remote code that they want to execute. So it's going to say require child process.exec. So if anybody is familiar with JavaScript or Node, this is like os.system in Python or whatever. This is basically run a shell command on the underlying instance, right? So child.process.exec, and then what we're going to exec is ls. So we're going to run ls on the machine. So a Linux machine, this would definitely work. And then it's going to run this function to log it to standard out. right? So we're going to log whatever the output of this ls command is to stand it out, right? So we could play around with our app and see if it works and see if this breaks.
Yeah.
But so I went ahead and did a bunch of work for this. It took me a long time to write. I've actually wrote some tools which I've made available on GitHub for people if they want to like play around with this vulnerability or demonstrate or exploit it. So I've wrote like a walkthrough on this gist on GitHub. But really, what we want to do is something like this. So the method that I'm going to use to try and exploit this is slightly different to what you just saw on the where did it go? There, on here. So they've just said like ls and they've put it out to standard out, right, in their JavaScript code. So I like there's a little strategy that I like to use, which I think is really neat and I love it. And until someone showed me, it's such a cool idea. Are you familiar with ngrok, Jason? The tool for like
I love ngrok.
tunneling to your thing. Yeah, so I'm going to use. We spoke about ngrok because I had the inspect window up earlier, right?
Yeah.
So let me just take a drink of water.
Hey, I got your GitHub repo up or your GitHub account up. Which repo was it? I'll just send that link in the chat.
It's a gist, but let me just make sure it's Did I make it public? In fact, there's a repo in there called Serverless Security Workshop.
Yeah, I see that.
Yeah, and that's basically all this code and everything for this.
Great.
This stuff.
I'll just drop that into chat for everybody.
Cool. All right, so so basically what we're going to do is we want to run a bit more advanced code. So what you can do is you can run some code on the machine, whatever the output is. Say it was an ls, for example, right? You base64 encode the response and then send it as a query parameter to an ngrok endpoint, right? This is like a command and control kind of server, right? So I'm going to send my malicious code to my function, and I'm going to get my function to call back home, right, and send me some data. So because I can't have access to standard out, whatever, right? So so I'm using ngrok for that. So I've got I'm going to set up in a moment like a HTTP endpoint on my machine. I'm going to ngrok tunnel to that, and then I'm going to send some malicious code to my function. It's going to run that code, which is going to get something that it shouldn't have access to using the child process and send that back to my ngrok endpoint as a query parameter. Then I can decode that base64, and ta-da, we've got some information from the underlying system.
Wow. Okay.
What that's going to look like is here, right? So we've got const exec equals required child process. So we're using the child process. We're going to define a variable called command, and I'm actually going to run a curl command. Remember, this isn't a JavaScript command. This is a shell command on the underlying instance. We're going to curl my HTTP endpoint, and then I'm just going to pass this parameter in called data equals, and then run like $, then run the ls minus la /temp. So I'm going to look at what's in the /temp directory. I'm going to base64 encode it, and when I do wrap 0, it means that I don't get I get the whole thing. It doesn't care about the lines and like the carriage returns in the response. So basically, my ngrok endpoint should receive a request, but then when I look at the data endpoint, it should be the output of an ls on the actual underlying functions host.
Okay. That's
and
cool.
I can decode that. And then we're going to exec that command basically.
Yep.
So what's hard is that you try and run this bit of code inside here, and you're just going to have a whole load of pain. Like for everyone watching this, like I've been through all the pain here, right? You've got to like escape 1 million characters. You can't have carriage returns. You've got to get all your code on one line. And it doesn't like the semicolon. It's got backslashes all over the place, and then you forget to. It's a complete pain in the backside to do, right? So, so what we can actually do is I just encoded like all of this as hexadecimal. So this is basically that code as hex.
Got it.
And then what I can do is I can send a request here like David Williams, blah, blah, blah. He works for Big Dave's Shellfish. You can see how like creative I was getting with these fake company names. And I've added an extra parameter to that speaker request called naughty. And then in there, this might look familiar by now, right? This is that exploit that we see.
Right.
But inside the code, I'm just going to just eval new buffer, and I'm going to pass in the hex here. And then I'm going to turn that hex to a string. So I'm going to run basically that command, but I've passed it as hex, which has just saved me a heck load of escaping characters
things out,
and,
exactly.
and all that kind of stuff. So this is still a bit of a pain, to be honest, right? So like every command I want to run, I need to write the command. I need to write the JavaScript. I need to encode it as hex, and then I need to formulate like this line. And I was doing that for ages when I was first doing this. I was like, writing code as hex, blah, blah, blah. I was going through and I was like, I've heard of these things called bash scripts. Like, you ever heard of bash scripts? You know, like I could just like I could automate this whole thing. So I created a little tool called, it's called like generate payload or something, .sh. And this is also available. And basically, you just run like /generate payload. You give it a CLI command you want to run, and then you give it an ngrok URL for your current ngrok endpoint, because that changes every time you create a new ngrok tunnel. And then it generates that malicious payload for you that you put in that naughty parameter.
Got it.
So this, like, I don't need to walk through the bash here. I mean, I can, like, it's literally just like, yeah, you can see like the exploit code here, and then I'm doing some like crazy sed stuff to like make stuff out, and yeah, I'm turning it into hex and stuff, like all this fun stuff.
I do love seeing a good bash script though.
What a bash script! Oh, to tell you what, I spent a lot of time on like the colors. They're like yellow, like I define like green and yellow, and then everything's like wrapped in colors, and you have to close them all out like NC. And,
oh gosh.
Yeah, I like a
artisanal script.
I like a colorful bash script. Yeah, it has to. So where are we? All right, all right. All right, so in here, I'll make this bigger actually, folks. Oh, that's weird. All right. All right, so if I do, let's see what that is. That's cool. All right, so this is what the command's going to look like to generate the payload, but right now I don't have ngrok running, right? So let's do that. Here we go, like that worked. So we run ngrok here. This is giving me my ngrok URL.
Yep.
You know, I just moved over from my Windows machine back to my Mac, and I'm doing like Control Shift to copy in the terminal, and it's just cancelled my whole ngrok thing. I can like, this is great. I can just copy now. All right, so I'm gonna just put that in there, and ta-da, it's done all that work for you, right? And I can just take this here. Sorry, you need to admire the colors first. So it's telling you it's generating a payload for this command. It's giving this. This is the ngrok URL we're going to go to, and this is what the malicious code looks like. So it's done all that hex stuff and all that boring stuff for you. I think I might have to like Python. Yeah, let's just run a little HTTP server so that ngrok doesn't complain at me. Let me just go back to ngrok inspect, and it should actually work. Here we go. So it's saying we're not getting any requests, right? So what I can do now is I can go back to my bash thing here. And this is I can just copy this out here. Copy that. And I can go to Postman. I've got these kind of saved to save us some time. So here we go, this guy called like Bob Harris. It looks very similar to the one where it said like Dean, like it's a normal speaker, but again, I've just added this extra parameter called naughty.
Right.
And I can just paste that payload in there, right? So this is basically going to go and run an ls on /temp and send it back to me. So,
is it? Sorry to interrupt, but does the XML or the JSON that it's expecting, and I know this is going to be app specific, does it not expect the schema to be specific? It feels to me like that new field for naughty, it would just ignore it or give you a 500 error or something.
Yeah, so so no, but it should.
Oh, I see. Okay.
Right.
Is
So like, and this is actually the crux of like, this is almost the crux of like lots of like 90% of AppSec, right? It's like the front door to AppSec is input validation,
yeah,
right?
yeah.
Like it's funny how you said like earlier, like, oh, static site that I'm deploying, like I'm not really care about right click publish. And I'm like, well, where users aren't inputting data, like your attack surface is like significantly less, right? In fact,
Absolutely.
I've worked with startups in the past and I've engaged like with pen testers and ethical hackers to test their apps, and their quote is based on how many input fields there are,
Right.
right?
Yep.
Because that's what they're going to go and do. They're just going to smash a load of data into those fields and see what sticks, right? Same
Mm-hmm.
here. You just put this in every single field, right? If this was a form,
Right.
right?
Exactly.
I could try it on employer. I think it would actually work. Actually, we can test that in a moment. Let's do that. I think I could probably just put this inside a field that it was familiar with, because we're deserializing it. So as soon as that unserialized function sees this, it's going to run this code, no
Oh,
matter where it
okay.
is.
You're saying it doesn't even need to be its own variable or its own name. You could just use one of
Yeah.
the existing ones. Okay, cool.
Well, let's look at the data from this, and then we'll
Sure,
try it.
let's try this
play
first.
around.
Yep,
Yeah. But yeah, input validation is like
definitely.
is king, right? Yeah. Wherever somebody can put information into your system, like even, by the way, just a side note, even authorized users, right? Because like, I can create an account on your SaaS app, right?
I remember
You
one
know?
time I was I can't remember what I was doing. I was writing some query, SQL query, and I had something in my clipboard, and then I went up and like pasted it into the browser URL, browser window to like, go to just to like see what it did, and I don't know. Somebody was sitting right next to me, and like, dude, you don't even like that could totally melt down somebody's system by just throwing random shit into the search bar in a browser.
Did you have like the feds turn up with guns and everything? Like, straight?
No, thankfully.
Nice. So back at ngrok. By the way, ngrok has got this great inspector. If people are watching this and aren't familiar, like it's great. You can see all the requests coming in, what's going on. It just runs on localhost 4040. So here we go. Like we've received the request, right? So my function app in the cloud in Azure has queried back to my control server, right? My malicious endpoint. And all of this is pretty boring, but as we expected, inside the query parameters, here, you see it there, we have like this base64 data, right? And if we click at raw, I can just get that out of there, copy that into some like base64 decoder. Ta-da, right?
Boom.
So here you can see, right, that make it bigger. Always make it bigger. The within that /temp folder, right, we've got this bob.json file. I wonder what that is. My name was Bob when I submitted it. Like without even seeing the code, we now know that they're writing data to /temp. There's another folder in here. There's some other stuff like some logs and all sorts of fun stuff. This zip file, I'm not entirely sure what that is. But this isn't like the only command that we can use, right?
Yeah. What
we need to do from this point is, this is where if you realize you're attacking like an Azure environment or something, you need to familiarize yourself with the service that you're attacking and the underlying system. And if you're building these systems, you should be familiar with the system that it lives on top of, right? This is where the function app, right? We have multiple functions in this function app. Let's go and see if we can access the source code of other functions, right? Not just this function that we're requesting, right? Let's have a look at the environment variables. Let's have a look at the identity associated to this function, all right? In Azure, we use in-app service and functions, and on virtual machines, we use something called managed service identity for accessing other resources in Azure. And the way that works is that there's a local like endpoint that runs on the underlying host, and it's called the MSI endpoint. And you query that endpoint and you ask it for a key for a particular service. So you query the MSI endpoint. Now I can show you exactly what you do.
Okay.
So let's have a look what we've got here. It's down on this machine. Yeah, here we go. So we can do like an env to get the environment variables in the machine, and we can grep for MSI, right? Managed Service Identity, right? This is where the most important things. And basically, it's a local endpoint that runs on our machine, and you need to hit the endpoint and ask for access to a specific resource in Azure. So here we're running a curl command. Ignore the secret for a moment, to the MSI endpoint, And the resource we want is storage.azure.com. So we're saying, right, give me a key from storage.azure.com, right? And this is great because it means that we don't have to store keys in our code, right?
Mm-hmm.
We can just ask this. But what you need is MSI secret. Right, so the reason we have this secret is really, really important. This stops server-side request forgery, right? This is how they believe the Capital One hack happened in the cloud, another cloud provider. But you can go Google and find out the story about that if you want. But that was server-side request forgery, and doing exactly this, leveraging the metadata service on the underlying instance to access keys. What that cloud provider didn't require at the time in their version 1 of their metadata service was a secret to access that service. So server-side request forgery, for those that aren't aware, is where maybe you're running like a proxy and you receive some input from a user again, and then you go and request that site for the user. So your proxy in Google, someone puts Google in, you then go and request Google for them. Somebody puts in the MSI endpoint in there, right? Into that request, you're going to go get the MSI endpoint for them and give it back to them, right? That's where cloud providers have been vulnerable to, not cloud providers, but people in the cloud have been vulnerable before to server-side request forgery. That's not really as easy to do in Azure here because you need this secret, right? If somebody put a request into like a proxy running on VMs or here or whatever, and we were going out to request that data for them, we would go to the MSI endpoint because you didn't have the secret. We'd be like, screw you, see you later. So you need this secret to pass that as a header, and then you can query the endpoint, and it will return back a key, the response will come like this, right? It'll be like an access token. This is a JWT, a JSON Web Token, encoded, and it tells you like when it expires, what service it's for, and it's like a bearer token, right? So this is what it would give you back if you were permitted access. But we've got remote code execution on my function. We forgot about that, right? So I can run all these commands, right? So if this function has managed identity and access to a storage account, I can just run this command, find out what the environment variables are called. Then I can use my script and run this command. I can use my script again. I get a key for key vault, right? And then we can really start getting some interesting information and see if we can start branching out, right, into the cloud environment. This is one of the, it's not a danger, I don't want to say it's a danger of the cloud, but it's something that you need to be aware of, right? As soon as somebody, in any environment, right, what does an attacker do, right? They break in and then they're starting to pivot, right? And they're going to move sideways, right? And they're going to try and branch across your environment, right? They'll enter via the weakest point and then they'll start working their way across your network. And if you limit the number of resources you have in a subscription, if you limit the number of functions in a function app, if you adopt least privilege principle when doing resources, then like this function should only have access to the table that they should only have access to the table that it needs access to, right?
Mm-hmm.
If this has got access to the entire subscription, then that's a bad thing. Like we shouldn't really be doing that.
I feel like one of the links that you gave me, I'm going to share, was specifically talking about this type of stuff, the serverless security, Azure functions, right?
Yeah, exactly. Yeah, and there's another link I shared you actually, which, in fact, that's slightly different. We'll talk about it in a bit. But yeah, it covers some of this stuff about blast radius and all that. But we'll play around with this in a minute and see how it works. But
okay.
We can do this. Like we can run these commands. But what happens is these tokens is like there's more recon we can do at this point, right? This is more information. So when we get a JSON Web Token, if people here are familiar with OAuth and bearer tokens and stuff, right? You can put that into a decoder and you can decode that JSON Web Token, and ta-da, we've got more information about this account now, right? We've got the app ID for the identity, which is what Azure Active Directory uses as the app ID, right? This is no use on its own, but we're starting to build this picture and building this kind of network. I think of it as like, you know, when you watch like the detective series and they've got like the pins on the wall and they're like mapping everything together and like throwing the thing, like this is what these bad guys would be doing, right? This is the subscription ID.
Where do you keep when you're collecting and investigating for all these little different things? Where do people put it? They put like in a scratch pad somewhere. Like how do you?
Yeah,
keep
a
track
lot of people
all this
use
stuff?
like mind maps.
Okay.
like for like, you know, where you can like map and link things and have like sub things off of things and stuff like that. So you would find like, okay,
Yeah.
well, I managed to get into the function, and then the
Right.
function had access to this identity, and this identity gave me this token, and then like try and map it out like that a little.
Definitely starts to look like the pin board with the yarn.
Yeah. Or exactly that. You can get some cotton wool and a pinboard, and
Yeah.
that's what's over here in my office. Yeah, I haven't shown you that, but yeah. I
My
wish I
picture's
was that cool.
my picture's not on it anywhere, is it?
Yeah, exactly. Yeah, I've got you up there, right? And you're like the big face in the center. Like, how do we find this kingpin? Um, yeah, so like the subscription ID, right? This is useful, right? We know their Azure subscription ID is now.
Yeah.
This is the object ID from Azure Active Directory, right? For this particular identity, right?
Yeah.
What it actually tells you here is the resource group name,
Hmm.
right? So we know that there's a resource group called Serverless Security inside this subscription, right? What can we do with that? We can go, like, we can move completely away from this function now, and we can go to Azure CLI, all right? Because don't forget, like, as soon as we've got a token like this,
Right.
like, we don't need to use it. We don't need to log into the function anymore.
Exactly.
Like, this token gives us full access to storage. Like, we can just use that in an application somewhere, like a completely independent application. This is all really, really useful stuff to just think about how, like, protecting these is hard. Like, this data has to be in a JSON Web Token. There isn't really an answer for it.
Yeah.
But making it so people can't get your JSON Web Tokens and making sure you're not vulnerable to RCEs is like, it's probably a good
So
step
all this
towards
stuff's
that.
just out there, if you know how to ask for it. And
Yeah, exactly.
and we've got like 30 minutes left before we're done today. How do we protect ourselves from? I'm assuming that's
Nice.
kind of kind of like the next part of this, right? Is like,
yeah, exactly. I'm going to take 2 minutes to show you something really cool,
okay,
which I think is really cool, and you can all tell me and like boo and hiss and throw tomatoes if it's not. Like, I'm a big
you come up
boy.
with a way of doing that. Virtual tomatoes.
Yeah, I'm sure you can add something in Switch or something. The so one thing that I think is cool is like, so generating this payload is cool, right? We'd run that simple CLI command, right? And it gave us this payload, right?
Mm-hmm.
But what everybody really wants is a reverse shell, right? We want to actually get shell access as an attacker onto the underlying functions host. So I worked out how to do that in Azure Functions using this same vulnerability, which is more fun than just keep generating commands, because then you're on the shell, right? You can do whatever you like. So, so the reverse shell here. So we're going to use ngrok again, but I'm going to use TCP version of ngrok. Which is great, not just for web. You can use it for TCP. It's free to use for TCP, but you do need to have an ngrok account. So if people want to do that, you'll need to sign up for an ngrok account. So let me just cancel my web server. I'll cancel that, and I'm going to do ngrok TCP 3006. Now, this is slightly different, right? The URL is always the same. It's just the port number that changes. So I'm on 15447. Whereas before, like, the URL was unique. So all we really need here is the port number. And then I can go and use... That's really weird. When I clear and then I zoom in again, it brings back everything I cleared. That's all my ZSH for you. And then we use Netcat. So Netcat is actually an open source free tool. It's just a listener. Mm-hmm. So we're going to basically say listen. So similar to in Python, I run a web server on 80 to listen on 80. I can do this on TCP using Netcat. So I'm going to do Netcat -L 3006. So if you go to this ngrok URL here on 15447, it's going to send you to this Netcat listener here in this machine.
Okay.
So I have another tool here, which is similar to the one that we did last time. Where is it here? But this time the code's slightly different. That JavaScript code we want to turn into hex is slightly different. We're going to require net, so we're going to make a network connection. We're going to use child process, but instead we're going to spawn a bin/sh. We're going to spawn a shell on that child process rather than actually running a command on that child process. And then we're going to open a new socket. We're going to connect back to our ngrok endpoint, and then we're going to pipe that information out right across that network. This is pretty, and then again, we're just going to convert that as hex, and then turn it into this, put it in the function, and we'll decode it in our code to a string. So super simple. Where's my command gone? ngrok, my port was 15447. So I should just run my tool and do -p 15447. Yep. Make sure there's the space. And that's going to generate another payload here for me, which is like, whoa. Oh, that's better. Which is slightly longer, right? I'm going to test what you said here, actually, Jason.
Okay.
You know, you said we put it in a different parameter.
Try it in a different one.
Yeah, so we can just like delete naughty completely. And we'll try it in like postcode. All right, let's see if that works. So let's change the name to like Sally Harris or something, and then we'll send that. Okay, so we got it back. Thanks for submitting your details, Sally. Right. All right, cool. We're not, but when we go back to our netcat machine, oh, I didn't like that. Let's run that again. Let's see what happens in the same time. Ta-da!
Hey, look at that.
So here I am. I'm literally logged onto the Linux host running my Azure functions. So here, like, I mean, the world's my oyster, right? And this is all just from running a vulnerable node module.
Yeah.
Right. So I can do like env.
Like what?
Pipe. Oh, where's my pipe? I've moved to Mac. Where's the pipe? There it is. There you go. There's my MSI endpoint and my secret. Right? I can now go and start getting keys. Right. If this is using MSI, I can go like ls. Did you notice this? Like one thing we didn't mention is like this list invoices. I did that as like a bit of a decoy. Like somebody in the finance department is using the same function app as somebody in speakers, right? So I can just do like ls. So like if that's another good, like talking about fixing things and making things more secure, right?
Yeah.
Another good example here is doing the like not having like, what's the best way to put this? Like deployment boundaries between teams, right? Like only one team who are responsible for like this code and have the same security practices, etc., should be deploying to this function app, and even this resource group, arguably this subscription, right?
Yeah.
And then don't let multiple, because that you might not trust the developers in another org, even within your same business, unfortunately, right? That's just the reality of how some large organizations work potentially. Yeah, we can like. It's annoying. You get a really crap shell and you can't press like.
I was gonna say it's kind of hard without an actual prompt. So can you do all your basic Linux commands from here?
Yeah, like
you can run top and see what all's running and all
that. I'm not sure. No, it's like a small container. It doesn't do a bunch of stuff. Like you can do like standard stuff like pwd and Linux, and like you can have a little look around and see what's on.
Okay.
You can run curl.
Gotcha.
Like
wget.
I don't think wget. I think I played around with that when. It's there as an option. Yeah, just saying missing the URL.
Okay.
So you can. There's a few bits on there. But yeah, like here I am. I'm in, right, and I can from here I can go and
We gotta patch your code, man.
What I like. We need to patch my code. We need to fix it. Yeah, let's do that. So I've actually tested. I generally get timed out after 8 minutes. So that must be like the hot time for the function.
Oh, I was gonna say it's not durable function, right?
No. So the function will go. The underlying host will go cold generally about 5 to 8 minutes.
Yeah, sounds right.
Just complete side note, but that's what I found when I was playing around with this. So like let's talk about what we found, right? So we found remote code execution, right? Let's look in like priority order, like how important these things are. Like we found remote code execution, right? That's bad, right?
Super bad.
And if we look back at our like right at the beginning when I said about the two things we care about like configuration and our code, right? So that definitely falls under our code in this scenario. And then we have vulnerable dependencies. Like ultimately, this is how we got this RCE, right? Through vulnerable node dependencies. So that falls under AppSec or code. We had no auth. That's like a config kind of AppSec thing, right? We didn't enforce HTTPS. That's a configuration thing. Well, it actually isn't, but I like to pretend that the managed identity here has like wide open access to the whole subscription, because like some people do that, right? That is a real thing that people do that. we had see. I don't know if people saw this, but we had like I cancelled out of that. But in our code here, in fact, I'm gonna just jump back in to show you here. But we had like we had secrets. It's so good when once I built this, I was like, I can just get a show every time now. Like it just works. It's so consistent. What is it like? Yeah, here you go. So we had like we've got this app setting here, speaker table connection string. We've actually got the full connection string for that table here.
Oh, interesting.
We could just go to Azure CLI and use that connection string.
Right.
You can just pass that as a command on CLI. So we saw that there, and also if we like ls, people must have seen this. It's so obvious. Why not ls that? Oh, you know,
Bye.
I wanted to cat that or whatever, but here it's here, right? It's in. Let's get out of this crappy shell and we'll go over here. I put this in here just for fun, like const admin pass equals super secret password, right? But this is the point, like people do store secrets in plain text in their code, right? We broke that function app boundary, like we put the invoices app inside our other one as well. That was something we did. And then we had information leakage. Remember we gave away the server type in the header. We returned a stack trace at the end. So how do we fix this stuff? Right. So we probably don't have time to actually fix it. Let's talk about how we do it. We're going to look at a couple of things quick before we wrap up. Input validation. We spent a couple of minutes kind of sidetracking about that.
That's always your first line.
For any remote code execution, like input validation is your friend. Not just the schema of the like your JSON, that's like really important, but also like the contents of those parameters.
Yeah, just making sure they're not putting in a character that's going to bonk everything. Exactly,
like special characters. Don't try and do that on the client, like in the web app, because then they just go straight to the API with Postman. That's going to like evade that. A web application firewall can also be really helpful here as well, right?
What are we talking about? Yeah, the front door. Is that like?
Yeah, exactly.
I think we had some notes on that. Yeah.
I feel like. Do you know what Blue Peter is? Do you know what Blue Peter is?
No.
It's like a TV show from like when I was a kid, and like it was from the 70s, 60s in the UK. We used to make things, and then someone would go, well, "Here's what I made earlier," and I feel like I'm on Blue Peter because here's what I made earlier.
Wouldn't it be great if we had and then they're just like, "Whoa, I just had
they put it from under the desk, like, oh, here's a front door, Jason.
That's also like cooking TV type of stuff, right? Like, oh, this turkey takes 7 hours, but here I've got it for you in 7 seconds.
Exactly, and you'd get a Blue Peter. You would have been given a Blue Peter badge for attending today, Jason. So maybe I'll get you like an Azure badge or something.
Oh gosh, we totally need that.
An AAA badge, right? That's what you need. So in Azure Front Door, and it's actually really simple in function. So I have a front door already created called Serverless Security Demo, and I won't talk much about front door, but for those who aren't familiar, this is like an application level layer, like load balancer, really distributor. It's not DNS, so it's not the same as using DNS to load traffic. It's actually literally proxying the traffic to your backend, right? It's not just getting a record and sending it to a backend. But it has a web application firewall built in. So on this particular one here, I'm pointing all traffic to my backend from the front door. One actual other way we would fix this is, remember that my HTTP trigger, like right at the beginning, had that anonymous, right here in my function.json. I got this anonymous here.
Yeah.
Like we can change this to function, right? And then in order to trigger that function, I would need a function key. What I would do is I would give that key to front door, but I wouldn't give it to anybody else. So then if you tried to bypass my front door and just hit my function straight up, you wouldn't have the key. So you can't get past it. You have to come through the front door.
Okay. Does it pull the key from Vault? Or
no, it's like it's not actually stored in the Vault. It's like the service key. You know, when you go into Azure Storage and you go and get the keys.
Yeah. Okay.
It's like the actual resource. Per function key. It's called a function key.
Got it. Okay, I'm with you now.
But I would put that into my front door, and then only my front door could access my backend, right? Nobody could bypass it, so you'd have to go via my web application firewall. So in here, I've got a web application firewall. I have a WAF policy that's here. and it comes with a bunch of like managed rules, like out of the box. So it's looking for simple, like there's some remote code execution stuff here, like Unix shellcode found, stuff like that. You're not going to find that. This isn't going to block mine because remember I encoded all the Unix code as hex.
Mm-hmm.
So I'm kind of playing a little trick to bypass this. Like, unfortunately, this stuff isn't going to find my naughty stuff because I'm being a bit too naughty. So, but you can go and create custom rules, right? So imagine, like, we're going to get to the vulnerable dependencies in a minute, right? But the answer here is that you don't use node serialize, right? Like, we all get that, right? We shouldn't be using that because it's vulnerable, right? But say, for example, you or I went to the dev team. We said, look, guys, this is like you really shouldn't be using this. They'd be like, well, we understand, Jason, what you're saying, but we really we don't have time next couple of sprints to like fix this, right? We're gonna have to do it. We'll put it on our backlog. We'll try and prioritize as quickly as we can. Yep. You could go and create a custom rule in here, and because we know what the exploit looks like, right? So I've created this serialized node custom rule, and I've enabled it, and it's like a match rule. And I've said that if a string inside the request body contains these ~ $ND, which we know is required to trigger this exploit, then we're going to deny traffic.
Oops.
This is just like this.
Sorry, I was trying to change the screen here so we can see you. Yeah.
Nice. So yeah, so we can say if the request body includes this $$ND thing, which we know is a bad thing,
yeah.
Then deny the traffic, right?
Gotcha.
Really, really simple. So we can try that. Like, this should be enabled. So rather than going to my actual thing here, I think I've got one. Yeah.
It's just like slamming the front door on that one known vulnerability, right?
Exactly. And this doesn't fix everything, but like if you in this specific case where like they were going to take a little while to patch that. So this is another malicious request here, but this time you see my URL is azurefd.net, not azurewebsites.net. So I'm actually going via the front door. And I get a 403 back that says, naughty, behave yourself, right? This is my custom 403 message. Yeah, got you. The feds are turning up. So the
you have 1 minute before someone knocks at your door. Right.
Exactly, yeah. So that's like a really easy way to fix some of this stuff. And more simple command injection stuff, like if you were just taking input and sending it to os.system or child process, like which I've seen people do. I saw this quite a lot in the early days of serverless when people were using like image magic, for transcoding images and stuff. It used to run as like a command line thing rather than a node module. It may even still do. So people would spawn like child process to send the image to image magic to do like transcoding or something like that. Generally using like a storage trigger. So if someone uploads something to storage, it would trigger the thing. But it would they'd use the name of the file or something. So you could just send the name of the file was like a Linux command, right? Was like the vulnerable code was like the name of the file, and it was like child process, and it would pass that to the thing, and then you're vulnerable. So, but that kind of stuff would generally be caught by the managed rules, the stuff that's built in. Right. All right. So that's like kind of input validation, web application. The other thing for input validation is like running web scanners, right? You should run like OWASP, Z-Attack proxy. It's open source, it's free. There's a plugin for Azure DevOps if you're using that. Probably a plugin for every other CI/CD solution out there, or any other web vulnerability scan as part of your build process, right? You should be doing this like as left as possible in your development lifecycle.
Absolutely.
Love it. And also like in your code as well, there's a JSON input validator for Node that's on GitHub that's available. It's really, really popular. And similar to you said, like it checks the schema. You can define what the schema is, what the predicted value is. It validates for special characters and stuff like that.
Yeah, I just remembered when I was building some stuff for the tour last year, and I was sending some JSON in through Postman, and I had like a typo or something that didn't match up with the schema that it was expecting, and so it just like kept failing. I was like, man, you can get that thing to just take anything. I couldn't even get it to take what I thought I was doing right.
No, exactly. Yeah. So that and a lot of like developers would be doing
totally different. And I was sending it to secure endpoint, HTTPS. So thankfully somebody knew better than me on setting all those things up. It was just a logic app. You know how the logic app kicks off with an HTTP request.
Got it. Yeah.
One of those things. So it expected a very specific schema, and if it didn't adhere to that, it just aired out.
It's a no-no. Yeah,
Yeah,
that's fair
yeah,
enough. Yeah, and most solid like robust APIs would do that and use that kind of input validation. Um, yeah, like rattling through some of these things, like vulnerable dependencies, right? You should at least run npm audit as part of your build,
mm-hmm.
but you should probably make use of a commercial tool like Sneak.io or White Source or something like that, which will give you generally like reports on that. It will look at your package.json in JavaScript, for example, and look for vulnerabilities in those packages and let you know, but only those packages, but the packages that depends on, because we know Node's got this like this tree of dependencies underneath every dependency that you have, right? So it will check the tree and let you know whether there are any sub vulnerabilities as well. So that's pretty cool.
We've got a comment in our chat. One of our viewers has just recently found out about Front Door and says that they're currently in love with it. Which, I was the same way. Like I learned about it, I would say, about a year ago. Weren't you, Dean, putting together one of the talks around?
Yeah, it was actually part of the Ops 50 talk for the tour,
right,
the Ignite
right.
tour. It was when in the section about like taking your apps global potentially
Mm-hmm.
and leveraging and whether you needed to go global. Actually, that's another. We probably come and talk about architecture on this show at some point as well.
Yeah, that feels right. And I remember seeing your demo on the Front Door, and I was like, wow, I had no idea that was even a thing. So yeah, I'm with you. It is really cool, especially if you're like, like me, like I don't know better on some of this stuff. So thankfully the tools will protect me. Like the Logic app wouldn't even let me, create an endpoint that wouldn't stick to a certain schema. But one day, maybe I get ambitious and I want to go write my own function and I start actually building things from scratch. It kind of scares me that I might be leaving vulnerabilities out there, especially if I'm relying on other packages, other tools.
Yeah, it's a tricky one. Front door's great, and like the fact that the WAF is in there now as well is really cool, because I was always a bit of a bugbear for me in Azure that, like, being completely honest, that you had to have like an application gateway inside your region to run a web application file in Azure. And I'm always a big fan of putting that stuff right out as far to the edge as possible as you can. Like I can remember using Akamai like 10 years ago, and they had a WAF right out on the CDN at the edge, and so being able to do that right at the edge is like a massive benefit. So I really like the WAF functionality as well. So a bunch of stuff wrong with this app, right? We can go through some stuff. What other stuff do we have? We didn't enforce auth, right? So we should be using function keys as a minimum, like I said with the Front Door demo. API gateways, logic apps calling our function, like just give them the key, no one else. But if you're using user input directly, you should be using auth with Azure AD B2C or some kind of OAuth client like Auth0 or something like that, right? There's some docs around that as well. I don't have them to hand, but there is there's like a serverless web app doc. In fact, maybe I've got.
Let's see if we can find it. We got a few more minutes before we got to say goodbye here.
I might have one here, and I'll send it to you.
Okay. Yeah, you want to drop it in chat for me?
Yeah, it's in the chat with you, not the chat with the.
Right. Got it.
The imaging. There's an example there of using that. We probably don't have time to really talk about OAuth and Azure Active Directory B2C, but you should use some kind of authorization method for your thing. Like that's a whole other topic in its own right, like application authorization.
Absolutely. Yeah.
The one thing that really bugs me a little bit, and I'm being maybe too honest on this show, as we like to be, is that HTTPS isn't enforced, right? So HTTP access is turned on by default in Azure Functions. So if you go and just create an Azure function, like it will be available on HTTP. And I know the team have got it on their roadmap to stop that, so that you have to actively turn on HTTP and only allow HTTPS. But what you can do is you can enforce Azure Policy. So Azure Policy is a tool that enables you to ultimately, at deployment time within Resource Manager, it checks against the policy whether what you're deploying complies with that policy, and you can set one for HTTPS in Azure Functions. It's a pretty simple policy. It's a little JSON document, and that means when anyone deploys a function in your environment and they have HTTP turned on, they haven't turned it off, then it won't allow them to deploy and it will throw an error. So that's it's a bit of a hack, because I feel it should be turned off by default, but it's turned on by default.
Yeah.
Yeah. If you don't want to do that, you can just go in the portal or via the CLI and you can just turn it off by like a single parameter.
Okay.
The other thing we can do, it's really cool, and I'm not sure if my thing's connected around like. So I've just come back to this Mac, so I've actually used the Azure CLI since I've been on it, so I'm not sure if it works.
Should be a little bit here so we can see.
I'm just gonna run my count thing on the side, so just make sure that I'm not. Yeah, that's fine. A little clear, and I'll bring you back. I'm gonna put my account details on the screen.
It's a constant struggle.
So you can run like, I'm not gonna actually. You can run this command here. In fact, it's not that. This command here is. Oh, I love this. Made it bigger, and you'll see my account details anyway.
Okay.
Oh, now my credentials have expired. That's weird. Anyway, it's basically this here, right? So AZ role assignment list, and then you give it the object ID of the identity that is assigned to your function. So we assign our function a managed identity, and then it gets like every identity has like an ID. And what you can do is you can run this command. It will tell you the assignments that are given to that particular function, right? So you can go through and do this for all of your functions and basically work out whether you have got least privilege or not, right? We should be doing least privileges. A function should only have access to the one thing it needs access to, right? Or the two things it needs access to. So this gives us a way that we can go and audit that, but really like use least privileges. This, if someone did break in, you did have some bad practices, like they can't download all of your customer data from blob storage or whatever, right? That's bad. One thing that's cool is I think I gave you a link to that actually before the show, which we should probably share, is that we have secrets stored in plain text, both in our code and in the environment variables. We have the connection string.
Yeah.
Application settings actually gives you this really cool ability to use key vault references in application settings. So say my environment variable is called storage table connection string, and then I give it a value of like @microsoft.keyvault, and then pass in the URI for that specific key. Then under the hood, app service and functions would go and just get that key for me using the identity assigned to the function. So assuming that my function had access to that key vault, all right, I've given it an identity to access that key vault. I would just say in my code like env.storage table string, and then under the hood it would go to key vault, get me that function, get me that key, and then present it back for use in my code, so that I wouldn't have to store any of those keys either in application settings or in plain text. I could just store all of my secrets in Key Vault, which is pretty neat. I think I shared a link to that.
It's super handy. Yeah, I just put that in the chat for everybody. I think the more I'm learning about Key Vault, the better it sounds to just do it, use it for everything. Well, we've got about a minute left. Dean, I appreciate you spending your evening with me.
It's been great fun.
I'm so glad that this worked out. It's been forever since I've seen you. Miss you. Glad you're doing well. And anything else in the last like 30 seconds or so, like stuff you got coming up? Anything you want to tell the audience, promote, anything like that?
I've got a couple of stuff coming up. Nothing to be announced yet, but hit me up on Twitter at Dean Bryen. We're going to be running some online Azure security days probably in October, just after Ignite. So that should be pretty big, like a whole all-encompassing stuff with some of this cool stuff in. I'm also running there's a new show called the Cloud Skills Show, which is being aired every Thursday at 2 p.m. UK time. Okay. And I'm running an episode on the Thursday, the 3rd of September, on Azure security, and it's a cool show. We bring in a couple of guests. It's like a TV show kind of format. I've got like 2 or 3 guests coming in for like 10, 15-minute segments, and then we'll be doing some demos and some cool stuff to show what people
is that where is that found? Is that on Twitch or somewhere else?
It's going to be on Learn TV.
It'll be on Learn. Great. Cool.
Yeah, Microsoft Learn TV, yeah.
Amazing. Awesome. Well, thanks again for being here, and definitely follow Dean on Twitter at Dean Bryen. And thanks again, Dean, for showing us how we can find out some of the existing, I guess you'd say, scariness of the internet when it comes to applications running out there, and how we can secure some of our functions, some of our serverless technology, specifically on Azure. So thank you so much for that. And thank you everybody who tuned in today. Thanks for the great conversations in chat. We'll we'll have all this information, show notes, and all that kind of stuff available to you later on. And enjoy the rest of your week and your weekend, and we'll see you next week. I'll be your host all week long, actually, Monday, Tuesday, and Thursday, so it'll be fun, and I'll see you all there. So take care. Bye.
Cheers all.